Howdy, it's Mr. Ryan here at RCA. I just have this kind of math and science in the real world kind of idea. So it's just, I've got this thing that hangs on the front of my podium. This podium is metal, and we got this thing that can hold, well, all kinds of stuff. I put pens and markers in it and highlighters, and it's got a big old magnet on the back of it. And so it just sort of hangs on the front of my podium. And the reason it's on the front is because I usually keep my podium turned sideways. But so here was the thing. I just put a couple pens in there, and then I accidentally kind of bumped against it, and it started sliding down the podium, you know. And it occurred to me that, and you probably already know this, but it occurred to me that that magnet that's holding this on to this metal, that magnet is only so strong, and it can only hold so much weight. And so I started thinking to myself, well, how many markers and how many pens can it possibly hold? Because at some point or another, this is going to have too many pens, too many pencils and markers, and it's going to slide down because it's going to be too heavy. Now, this is actually a mathematical concept, and we can explore it using science to try and understand. The idea here is, it's a question of, the word is marginal. It's the idea of marginal. You've probably heard the saying, the straw that broke the camel's back, you know, and that's the idea that you can load a camel with lots of heavy items. You know, you use camels in like caravans and stuff to transport items long distances, right? But eventually there's a point at which you have put too much weight on the camel. Now, even though, let's say you're putting heavy, maybe 10-pound bags on the camel, let's say that you put a 10-pound bag on, another 10-pound bag, a couple more 10-pound bags, then you put a 10-pound bag on the camel, and the camel starts groaning and maybe won't move because it's too much for the camel to carry. But it wasn't the whole 10 pounds that caused the camel to buckle or to not be able to carry the weight. In fact, we can granularly go down. Maybe it didn't happen at 10 pounds. Maybe it happened at 1 pound or 2 pounds or 3 pounds. And even if it happened at 3 pounds, maybe it didn't happen right at 3 pounds. Maybe it happened at 2.5 pounds or 2.6 pounds or 2.65 pounds. See, as we get to a more granular level, we understand that it could have been a single piece of straw that actually put the camel from, I'm okay with carrying this, to this is too heavy. So that's where the saying, the straw that broke the camel's back, comes from. Well, here in this particular case, if we keep putting pens in here, pens themselves aren't very heavy, right? But as the pens accumulate, now in math, in calculus, we refer to that idea as integration, an accumulation of something. So what I was thinking here is, there has to be a pen that breaks the magnet, right? That if I put another pen in, and then another pen, and this is how we can scientifically explore this, is we put one item at a time. And in economics and in other subjects, this idea is called the marginal unit. Marginal means with just one more, what happens? Okay? With just one more, what happens? So the marginal unit is always the plus one more unit. Okay? So here's what I want to do. My idea was, okay, I've got this, and in my pocket I happen to have 2 pens and a marker, and I know that you know that if I put in these items, that they all have weight, correct? These have weight. Here on Earth they have weight. They also have mass. Okay, so I know that by adding just a little more weight to this, it'll make the total weight higher. So as I marginally increase the weight, as I add one marginal unit, it increases the overall weight of all of the pens and markers, and this container is now carrying more weight. And so, well, it didn't slide down, did it, right? So I'm going to put another pen in, and looks like it's still okay. It's not sliding down. The magnet is still holding on. So I'm going to put this marker in, and I'm going to see what happens. Now I'm doing the best I can not to push it. I'm just trying to drop it in as lightly as I can, and it looks like it's still holding. Well, it looks like I need more pens and markers to find out when it's gonna break. I got 12 markers here. I'm gonna put them all in. One. You know what I might do? I can put them together like this to try and fit them in a little bit easier. 12. That'll make the 12th one right there. Okay. Still holding. So now let's go to this box, and in this box, maybe I'll do 2 at a time from here too. Oh, there they go. It actually wouldn't take any more from this other box. It took those 12 markers, but you can see clearly that at one point it was okay. It would hold them for several minutes. It probably would have held if I left here overnight, okay? Now it's possible that the temperature in the room might affect how well it holds, but it might not. But you can clearly see here that there was a point at which if you put too many markers in, or too many pens or something like that, that there is a point at which just one is a little too many, okay? And so this concept is in math and in some of the sciences is referred to as the marginal unit, and that is a mathematical concept. Maybe you can look up something, or you can explore something in your life, you know, where just one more is a little too much, that you're okay with a certain. Maybe you can find out how many cans of soda that you can carry. Maybe get some bags and you put maybe 5 or 6 in each bag and carry them with both hands, and then maybe put one more and one more and one more until you can't carry anymore, and that will determine the straw that broke the camel's back.